so today we're going to be going over this circuit problem that involves Kirchhoff's loop rule. So the first thing that we have is obviously the circuit. And in the question itself, they give us certain values already given, and such as the voltage for E1, E2, and then resistors, and then also one of the currents. So the first question is asking for the potential difference across R2, capital R2, in 5.10 volts. And they want us to calculate I2 and I3. So the first thing that I like to do when I approach a circuit problem is I like to redraw the circuit in a way that I believe is much more simple to read. So what I like to do is I like to find the starting point and where I want to redraw my circuit to begin with. And for me, that's the E1. So I'm going to write E1, and we know that's going to go forward. And from that, we're going to have I1 going this way. So let's follow the path of E1. Imagine this as like a car lane, right? You have a lane of cars going in one direction. So what's the first thing that you will come across after E1? Well, that's just the capital R1, right? If you were a car leaving from point E1, the next thing you'd see is capital R1. So let's write capital R1. The next thing you would see is lowercase r1. The next thing you'll see is that the car lane splits into two car lanes, right? So the circuit splits into two junctions, okay? So that blue point is to show where that split is happening. And you have two splits. You have one split going this way, and you have another split going that way. So let's write for the pink split. This is going to look weird, but this is what I believe is much more simple to read. If we do the pink path, okay, the first thing you're going to see that way is the capital R3. The next thing you're going to see is the capital E3. Well, just E3, not really capital, but yeah. And then after that, it joins back into another point. Let's color that yellow. Closes back up at yellow, right? So let's do the dark blue path now, the navy blue, right? So the first thing we're going to get there is the lowercase r2. The next thing we're going to get is the E2. And the next thing we're going to get is the capital R2, right? And then from there, it also meets at that yellow point, right? So in case you're confused, essentially the way that I'm viewing this is that you had one car lane that split into two car lanes. And for each lane, it had its own obstacles, or, maybe there was construction work or whatever that was in the way, right? And this is my way of portraying this, where you have the pink road, which has its own obstacles, which is capital R3 and E3, and then the navy road, which is just lowercase r2, E2, and capital R2, right? So then after they meet back up at the yellow point, they combine back into one road, right? And what comes after that point of convergence? Well, it just goes back to E1, right? Let me write that a bit better. In my opinion, I mean, this is way more simple to read and interpret than this mess, right? I think this is way more simple. So also what I like to do from this point forward is I like to label every battery and resistor with a positive and negative sign. So what I would like to do is I would give this a negative and this a positive, because I know that the overall current is moving to the right. right? So that's going to be positive. And then we know for every resistor that there's a voltage drop. So every time the current is leaving every resistor, it's reducing in voltage, which is why since it's reducing in voltage when it leaves right here from that end, it's going to be a negative end right there. So we're going to do the same here, negative end. Here's the thing, when you have the battery, isn't the battery, since it's going in the same direction, wouldn't it be having a positive sign, right? If you had a battery that was hypothetically going in, let's say, this direction, right, then it would be, oh, then it would be like this, right? But because the battery is going in the same direction as the initial battery, just to the right, then it's going to be having a positive direction in that right direction, right? So then we're also going to have positive there, negative here, positive here, so there, negative there, okay? So next, now that we've labeled our circuit and drew everything out, let's try answering part A. So part A is saying to calculate I2 and I3. Well, if we know that all of this is I1 and all of this is also I1, right? And the reason why it's all I1 is because the current is constant throughout the circuit. It's not being reduced, right? The only time the current is changing is when it splits into the parallel part of the circuit, okay? And when it's splitting into the parallel part of the circuit, you have two currents being made. You have I3 and you have I2, right? So the currents, they could be the same sometimes in a parallel circuit, but that's only if the resistors in the parallel circuit are of equivalent resistance. But in this case, they're not equivalent, so they're going to have different currents for I2 and I3. So since I1 is splitting into I2 and I3, doesn't that mean that I1 is equal to I2 plus I3, right? Because it's splitting into it. And then once it splits and you keep following that path, and then it goes to that yellow point, it's combining again. And when it combines, it's going to go back to being that value of I1. Okay. So we know now that I1 equals I2 plus I3. And they're saying that the potential difference across capital R2 is 5.10 volts. And to calculate I2 and I3, so one equation that comes to mind is voltage equals IR. Okay. If we were to find the current of I2, well, first of all, let's rewrite the equation as I equals V over R. And now let's also rewrite this as I2 equals V2 over capital R2, right? And they told us in the question that V2 is 5.10 volts. And we also know that from the question that capital R2 is just 5 ohms. And when you do the math, it's just going to give you 1.02 amperes. So now we have I2, right? So let me highlight that. So all of this is the work we did for I2, right? So we have I2, and we know from the problem that I1 is equal to 2.2. Well, now that we have I2 and we're given I1, and we know that I1 equals I2 plus I3, well, let's just plug everything in, right? So 2.2 equals I2, which is just 1.02 plus I3. And when you subtract 1.02 from both sides, you're going to get I3 equals 1.18 amperes, right? So now it's I3. It's pretty simple, pretty straightforward. All you have to do is find the current from that side, I2. We knew that I1 equals I2 plus I3. We're given I1, we just calculated I2, and now we just calculated I3. Okay. So let's do part B. Part B is saying apply Kirchhoff's loop rule to loop 1 in the direction shown to find E3. So if we're trying to find E3, okay, let's make a loop to do this. So if we were to make a loop, we could make this loop. And another way I could show this to you, which might make it easier. Like this. So this is one loop. So we're excluding the bottom of that parallel circuit. Okay. We know from Kirchhoff's loop rule that the voltage, sum of the voltage is equal to 0. Okay. So from here, let's plug in all the numbers. So we have E1, and let's look at this. E1, when we're reading this going to the right, is a positive sign on the left or right? It's on the right. So since it's on the right, it's going to be a positive E1. Let's look at capital R1. Is the negative coming on the right or the left side? It's since the negative's on the right and the current is going to the right, when the current leaves a resistor, it's leaving through the negative end. And since it's leaving through the negative end, we're going to be subtracting that voltage. So it's going to be minus I1 multiplied by capital R1. Next thing is lowercase r1. So that's going to be the same thing, minus I1 lowercase r1. And then the next thing is I3 and R3. So you're going to have I3 and capital R3. And then look, you have E3. And E3, the plus sign is coming out towards the right. So when the current goes through that battery, since it's leaving through the positive end, you're adding E3. Okay. So from here, let's plug in the values. We're going to have 0 equals 5 minus 2.20 multiplied by 3 subtracted by 2.20 multiplied by 1.5 subtracted by 1.18 multiplied by 3.5 plus E3, because we're looking for E3, right? That's the question in part B. So when you do some of the simplification, you're going to get negative 9.03 plus E3, and that's just going to end up giving you 9.03 volts. Okay. So there's another loop that we can end up making, and the loop that we can make for that is actually, here, let me do that. So before, we had only the top end of the parallel circuit. Now we're going to make the same loop, Kirchhoff's loop, but we're only going to be looking at the bottom half. It's like this, right? So let's start from there. So we know that the sum of the voltage is equal to 0. We know that we're starting with E1, just like part B. So E1 minus I1 multiplied by capital R1 minus I1 multiplied by lowercase r1. And what comes after that? It's lowercase r2. And what current is going through that? Well, that's just I2. So you're going to have minus I2 multiplied by lowercase r2. And then you're going to have, since you have E2 and the positive end is coming out towards the right, when the current goes through that battery, it's leaving through the positive end, meaning it's adding to the system. So you're going to have plus E2. And then you're also going to be subtracting capital R2. So it's going to be minus I2 multiplied by capital R2. So now let's plug in all the values, and you're going to get 0 equals 5 subtracted by 2.20 multiplied by 3 minus 2.20 multiplied by 1.5 subtracted by 1.02, and we're looking for lowercase r2. So we're going to keep that the same, and that's plus 12 because E2 is, let me write that better, E2 is 12, and then we're subtracting 1.02 multiplied by 5. So when you simplify that, you're going to get 2.0 minus 1.06 R2. And that way you're going to get 1.06 R2 equals 2.0. And thus R2 equals 1.96 ohms. So we found lowercase r2. We found E3. And I think this is a pretty straightforward problem. If you have any questions, you could leave them in the chat or just directly message me. And yeah, I mean, the best advice I can give you guys is you should really learn how to draw your circuits like this, because I've tutored many people with circuits. And the best thing that they said that helped them is just being able to view circuits in a way that was easier for them to interpret. And I truly believe that if you can do that for every circuit problem you come across, it will make your life way more easier. Okay. All right. Thank you guys.